Is it gonna let me write? What is happening? So I can write down here, I just can't write it there. Okay, well, whatever. 13.5, apply the law of sines. So this chart will be very useful in solving. You will just have to know this information. So you won't have it like in front of you when we do it, but anyways. So the first like problems in the section are to identify what case it is and then to decide if there's 1, 2, or no triangles. So number 4, we have A is equal to 40 degrees, C is equal to 75 degrees, and little c is equal to 20. So these are no longer right triangles. Not to say they can't be, but we're not going to assume that they're right triangles anymore, basically, in this section. So what we want to do is we want to draw a triangle, however you want your triangle to look. And I'm going to label the stuff that I'm given. Okay, so I'm going to do A, which would mean over here is side A. And then I can choose whatever else, but I'm going to say that this is angle C. I usually go ABC when I do it, but again. And then little c for side C because it's got to be opposite of its angle. So then I look, I have a side, an angle, and an angle. What case is that? Angle, side. So I have angle, side, and how many triangles is that from what you wrote down in your notes? Or does that one have?
The whole thing.
1.
Yep, one triangle.
That was gonna be my guess. Wait, are we just figuring out how many triangles there are?
For this one, yeah.
Oh, fun.
Oh. In the boxes. She couldn't find it. It was like the one thing on her page that's even boxed.
Oh yeah, I put the fancy bubble on that one.
It's always the things on
All right, 6. We have angle A is 37 degrees, side A is 8, and side B is 14. So again, I've got my triangle. I've got angle A, meaning side A has to be over here. Then side B, it doesn't really matter where I end up putting it. But just to be consistent with what I've been doing, I'll put it down here. So I've got side, angle, side, angle. And I will reiterate, it always goes in that order. Fun fact, I had Mr. Cass when we did this section before, or like when I did the section in high school. And it was during an ACSI accreditation year. So they were on campus, like going around and doing like observations and stuff. And so he like taught it. And so he wrote it the other way on purpose, like initially to like, you know, whatever. But he didn't want to like erase it. So he put a C in front of it and was like, look guys, I put my name on the board. It was really funny. And then he was like, obviously don't ever write it like, that was the point, like don't write it like that, and that's why. But yeah. Anyways, it was just yeah, because like that's why like he would read it off like, oh, this is angle side. It's like, no, it's side angle. So what are my options for how many triangles I can have with side angle?
0, 1, or 2.
Okay, so I can have 0, 1, or 2. So that means that now I have to do some more math initially. Or, first of all, I can look up here. I have options of A is acute or A is obtuse. So is my angle acute or obtuse?
Acute.
Acute. So I'm going to look up here. And if there's any situation, is A greater than or equal to B?
No.
No. So that means I have to find H because every other scenario involves H. So H is equal to B sine A. So B sine A. So that's going to be 14 sine of 37. And then you would need to use your calculator to find that value in degree mode. And we will do some where they don't give you like side B and angle A and like show you how to make sure you're using the right stuff to solve the formula because sometimes people get confused with that.
Is this whole section in degree mode?
Yes.
Oh yeah.
Switch back in probably radians.
I'm in degree.
A lot of what we will do moving forward will be in degrees, but not necessarily everything. But most of what's going in your calculator at least would be.
So what do you want it rounded to?
So we're going to do nearest whole number for, well, no, hold on. Let me back up. Your H value, you need to go out at least 1 or 2 decimal places if it's given to you.
8.43.
Okay.
Virginia, we were not like right there.
Okay, because we have this scenario of H is greater than A, H is equal to A, or H is less than A less than B. So H in this case was 8.43. If I round it to the nearest whole number, that's going to tell me that H is equal to A. Okay, but in this case, H is actually greater than A. Okay, so that means this scenario, H is greater than A, and so there's no triangle. And a lot of times I will do this so that when I look back, I know why was it not 1. So when you're solving for H, go out to at least 1, if not 2 decimal places. If you started with numbers that were decimal, go out to 1 more decimal place than whatever you started with. But when we actually get into solving the triangles with the angles and the sides, everything will be to the nearest whole number according to normal rounding rules, because it gets really annoying to have like a side length that's like 7.427. It's like 7. Okay, so when we get there, we'll talk about that. But that's why I initially said whole number, and I was like, wait, nope, because this is H, and that it can literally throw off a problem completely. You're like, oh, well, there's no triangle for me to solve for, and then it's like, oh no, there's actually, you need to solve it. So
were you able to tell that it was like an acute angle just by looking at it?
so acute means what?
Less than 90?
Okay.
Oh.
So I look at the angle that's given to me, and then I decide, is it acute or obtuse? Obviously the easier scenario is if it's obtuse, because you don't really have to do anything.
Okay. Would have been bad if I labeled it as the obtuse angle. Yeah. Thanks. Probably do it more. It's fun to have it.
It probably will at some point.
Yeah, probably.
My favorite one is when, okay, I'm just going to give you the hint, guys. If I give you a really tiny space to solve these, typically it means there's no triangle. Or it's a problem like this where I'm just asking you to tell me how many there are. Well, inevitably, every time I pick one that's a no triangle problem, somebody solves it. And I'm like, oh, that's nice. Especially when it's obtuse and they didn't even have to do any work. I'm like, okay. I'm like, good try, but no. Like, so.
A for effort.
Yeah, you're like,
F for brave.
That's funny. But yeah, so anyways, if there's not a lot of space to solve the problem, 98% of the time it's intentional.
Okay.
Trying to help you out. All right, number 8. Angle A is 149 degrees. Side A is 7. Side B is 10. So again, I've got my triangle. I've got angle A, meaning side A is over here. And then, like I said, for consistency, I'm just going to put side B down here. Now, when we get into solving them, I may adjust it a little bit because side B needs to be over here. But for the purpose of these, I'm just going to do it like this because it really doesn't matter. So, as long as you have everything on there, it really doesn't matter. It's just a matter of if it goes side angle here or side angle this way. So it doesn't really make a difference. But so this one's another side angle. Oh, wrong color. Whoa. I want my pink back. So we have side angle. I need to look now at what scenario am I dealing with. So first and foremost, is my angle acute or obtuse? Obtuse. So I go up here and I look. So I have either A is less than or equal to B or A is greater than B. So which one am I dealing with?
Less than or equal to.
So A is less than or equal to B because 7 is less than or equal to 10. And that means what?
No triangle.
No triangle.
I thought we were just looking at the whole time. I was like, how do you know this kind of stuff? I totally forgot that like really gives it to you.
Now, obviously, I'm making some assumptions about these triangles that I'm drawing, but I'm just drawing it so that you see where these things are. Because more with, like, you're, like, obviously not side, but, like, side, angle, like, some of those, sometimes they can get confusing because of where they are. So I'm just drawing these triangles, but technically, when I draw this triangle, I don't know if it's going to exist yet or if there's going to be more than one of them or, you know, just the one or whatever. So that's why, ultimately, they will be... When I get there, it'll be drawn more like this because angle B will be what I'm solving for. So I say that and then they're going to change the letters on you, but the principle of the matter is that. All right, 10. Angle B is 70 degrees, side B is 85, and side C is 88. So now this one's a little bit different. I'm still going to put the angle that I'm given here. Okay. That's always where that one's going to go. B is over here. Now, based on the fact of how they're drawn in those picture diagrams, I'm going to go ahead and make the transition of putting it over here just because that way we're getting used to it as we get ready. This is, I think, the last one before we actually start solving. So that way we're starting to transition into that way of drawing them. But now I've got side, angle. Okay, so still, it doesn't matter what order they're in. Like I said before, they still exist in the same area. So side, angle. Now, for the purpose of just visualizing it, okay, this is in the formula what I was given. Now, it's given to you with different letters, so I'm going to use the letters given, obviously, but I want you to see in the formula that's where I'm getting stuff from. Okay, now, is the angle acute or obtuse? Acute. Okay, so I'm going to go look at, right now I have B is less than C, so that's the first thing I'm going to see if that, or what it would have looked like before would be that A is less than B. So do I have that scenario anywhere? I have that here, but I still need to check H and make sure, okay, because H could come out to be equal to B, so on and so forth. So I'm going to check H. So my formula modified is H is equal to C sine of B. So it's always going to be the side that doesn't have his friend with him, okay, his angle friend, and then the angle that his friend was given to us. Okay, so that's why it's C sine B. So then 88 sine of 70, which is what? 82.69. So then how does H relate to those?
It's less than.
It's less than. So the only option that I had was that H could have been potentially equal to, in our case, B. It was not. So it's got to be H is less than A less than B, which means two triangles. So H is less than B is less than C for our scenario, which means two triangles.
If like on like homework and stuff, if we like relabeled it on the triangle as like a little b, then would it still be right, or do we need to keep the letters the same and just?
I don't mind if you change them. Just know that be careful, because when we get to solving the triangle, we're solving for all the angles and all the sides.
Okay.
So it will get confusing, I think, if you change them. But if you just need to, in your mind, change them to solve for like H, to know where the things go, that's fine. Just make sure that things get put back, because ultimately the formula for law of sines doesn't matter.
Yeah.
But otherwise you're gonna give me like angle C to really be my angle B or something like that, and it's gonna be like, whoa.
Yeah.
Now, I would probably recognize that, but I would prefer you to keep what it's supposed to be.
Yeah.
Because then also if it was a given triangle, because like the ones we're about to do, they're actually going to give you a triangle drawn already.
Mm-hmm.
When we get to the ones where you have to draw them yourself, it'll be a little bit different. But when they're given to you, it's like, okay, things need to be where they are. So, all right, so these first ones say to solve triangle ABC. So number 14. Now, I probably will only do one of the ones where they already give you the triangle, because they're obviously significantly easier than the ones where you have to do it yourself. But this triangle looks kind of like that in their picture. They have labeled this to be A, B, and C. C is 81 degrees, A is 33 degrees, and side C, which I'm going to go ahead and label, is 26. Then obviously I'm looking for side A, I'm looking for angle B, and I'm looking for side B are the things that I'm trying to find. And if you need to use, want to label with colors what you need to find or whatever, that's fine too. So I was given an angle, and a side. So what scenario is that? Angle, side. I keep trying to say them not in the right order, but I inevitably do. I guess just have it. So angle, side. So how many triangles can that have? One. Okay, that's the other thing. Always check which scenario you have, because in the past people have been trying to find H, and H isn't even needed because it's not side angle. I'm like, I don't even know how you're finding H, because you don't even have the right information. Anyways, it's fine. So angle, side always gives you one triangle. So now I just need to solve for it. Now with these problems, I'm usually a little bit more like, just tell me what the three pieces that you need to know. You don't necessarily need to rewrite everything, but I won't. Obviously, I'm not going to take off if you rewrite everything, just to make sure you've got all your bases covered. But I usually go ahead and write off to the side what I'm trying to find. So I need angle B, side A, and side B. So how would I go about finding angle B? Because that looks like the easiest thing to do first.
180 minus 81 minus 33.
Which will give you what?
$66.
66. So 66 degrees is B. Now, these are the problems where I was mentioning previously. Do your best to use the information that is already given to you. Okay, now with the angles, when you've already had two angles and you're finding the third one, not a big deal. That's okay to use. But I try, because eventually you're going to have to, because we didn't have angle B or side B, and to find it with law of sines, you have to have one of them. So we are going to have to use that. But I always try to use information that was given to me, not information that I found. So like when I go and find side B, I'm not going to use side B to find side A, basically. I'm going to use C because that was where everything was given to me. So I am going to start out with finding side A. So law of sines, now I need side A, so I'm going to use the formula where the side length is on top because that's what I ultimately want to solve for, so I'm trying to save some math steps. So I'm going to have A over sine of A, which is 33. So sine of 33 is equal to the stuff that I had all the given information for because I need to be able to solve for one variable, and if I put B in there, I can't solve for B. So I'm going to have 26 over the sine of 81. So ultimately, when I type it in my calculator, I'm going to have A is equal to 26 sine of 33 divided by the sine of 81. And again, we're going to the nearest whole number according to normal rounding rules. Completely wrong number on my paper. That's nice. All right, and then to find B, I'm going to use, obviously, C again. I'm not going to use A because that's just been found information. So then I have B over the sine of B, so that's going to be the sine of 66, is equal to C. So 26 over the sine of 81. And so then we multiply by sine of 66. So B is equal to 26 sine of 66 over sine of 81. What do we get?
24.
How much?
24.
I had the answer all wrong on my paper over here, so I was like trying to, like going through and checking in the book, and I was like, I had that angle B was 39 degrees, so obviously that threw things off just a little bit. I'm like, oh, I was using it to explain why we don't use the stuff that we found. Definitely just a mistake on my paper. It's okay, it happens. Okay. Let's see. All right, I'm going to go to the ones where they are giving me information but not actually the triangle. So 18, I've got A is equal to 73 degrees. Little a is 18, and little b is 11. So, just looking at this without me ever drawing a triangle, what scenario is this?
Side angle.
Side angle. So now I need to determine how many triangles I have. So first of all, is the angle acute or obtuse? Acute. So right now I have that A is greater than B. So let's look at, is that a scenario that I have for A to be greater than B? Is that one I have? Okay, so how many triangles do I have? One. So one triangle. So then I've got my triangle. I've got A here, side A here, and then for the purpose of just consistency with how they're drawn in the picture, this is side B over here. So again, given information is here. So now this one is going to require a lot more of law of sines because I only have one angle given, so I can't just like imply the other angle. So I'm going to have to solve for angle B, angle C, and side C. Oh, that's B. So those are the things I'm solving for. So I can't do anything with C yet because I have no piece of C. So I need to do B first, and then I can use that angle to help me find angle C and then go from there. So angle B, now I'm solving for the angle, so I'm going to do the one where sine of B is on top. So it'll be sine of B over 11 is equal to, I have to use A because that's what I have both pieces of, sine of 73 over 18. I have to multiply by 11, so I've got sine of B is equal to 11 sine of 73 over 18. Now, I've got to get B by itself because I'm trying to solve for. So going back to 13.4, to undo it, I'm taking the inverse of it. So B is going to be equal to the inverse or arc sine of 11 sine of 73 over 18. So you can actually type this in just as this is. You can do the arc sine button, and then in there you can do 11 sine of 73 and then do the little divided by, well, you need to close the parentheses on sine if you're going to do it all as one. Or you can find 11 sine of 73 divided by 18 and then do the arc sine of second answer, and then it'll type that in as well. But
What do you want it rounded to?
what did I say I wanted these rounded to?
Whole numbers.
Okay, there's your answer.
36.
36 degrees. So then how would I go about finding angle C?
180 minus 73 minus 36.
And then that gives you what?
71.
71. And then side C, I obviously have to use the found number of 71 for the degrees, but that's fine. So C over sine of 71 is equal to, I'm going to use A, 18 over sine of 73. So C is equal to 18 sine of 71 over the sine of 73. And sine of 71 and sine of 73, they're so close, they should be, in general, a very close value, okay, almost like 1. So if you get something that's like super obnoxious, obviously something's wrong. $18. So then there has been solved.
Why couldn't we use the Pythagorean? Oh, never mind. That's only for right triangles.
I was gonna say, gotta be a right triangle first.
Yeah.
All right. Let's see, 22. We're given angle A is 55 degrees, angle B is 64 degrees, and side C is 34. So with this one, I would go ahead and probably write out where these things go before you do anything. Even if it's hypothetical that I don't have a triangle, I can still at least see what scenario I'm working with. Sometimes I have a hard time seeing it if it's not visually given to me. So what scenario is this? Angle, side angle. And how many triangles does that mean? One triangle. So ultimately, I'm going to be looking for angle C, side A, and side B. So looking for a cab. So I'm going to put in the stuff that I knew. So 55 degrees, 64 degrees, and then side of 34. So what can I find first?
Angle C.
Which is what? Or how do I find it?
180 minus 64 minus 55.
Yep.
61.
61 degrees. So then I can find either side. That's a personal preference. But now the only thing that I have both pieces of is C, so I have to compare it to C. So do you want to do A or B first? A. All right, so I'm finding side A, so side length goes on top. So A over the sine of 55 is equal to 34 over the sine of 61. Multiply by sine of 55. So A is equal to 34 sine of 55 over the sine of 61.
I got an answer. I don't know if it's right though.
Okay, what'd you get?
32. Okay. Last time I did it and I did it completely wrong. Like you guys got like 70 and I got like 40 something. So just to make sure.
Sometimes it's about how you type it in your calculator, because when you hit like sine of 55, if you don't close the parentheses before you do the division symbol, it's going to think that you want to divide 55 by the sine of 61
Okay.
inside. So it's, yeah. So it's all about, there ends up being a lot of parentheses if you do these all in one step instead of in multiple steps. So then I need to find B. So B over the sine of 64 is equal to 34 over the sine of 61. So B is equal to 34 sine of 64 over the sine of 61.
Jinx.
Be nice and quiet now. I'm kidding. All right. Let's do one more and then we'll call it for today. I'll go ahead and give you a few problems just to try. And well, I say that you can try. There's like 10 minutes left, so we'll pick it up tomorrow. But 24. Yeah, we'll find this one. Angle C is 98 degrees. Side C is 29. Side A is 33. So at a visual glance, which scenario am I working with? Side angle. And is C acute or obtuse? Obtuse. So I'm going to look at that scenario. Now, if you need to see it comparatively to how it's normally written, this is angle A, side B. So if I obviously don't in this scenario, but if I had needed to do H, it would have been, for this particular case, A sine of C. So, anyways, but this is obtuse. So, here it says A is less than B according to the information we're given. So, which scenario is that? Or how many? No triangle.
Thank the Lord.
So this one is no triangle because C is less than A. So sometimes And if you go and if you like draw a triangle to see visually where everything is, and then it ends up being no triangle, don't feel like you have to erase it because it doesn't exist. Like, some people are like, oh my goodness, I have to erase it. There's no triangle. It's like, okay, it was a hypothetical one to begin with, so it's fine. Okay, are y'all inclined to start working on these if I tell you the problems now? Okay. Okay, you don't have to, but I will go ahead and tell you what they are. 3, 7, 13, 19, and 21 at the present moment, and then I will add to that tomorrow, but that gives you a little bit of a variety to start with.